So we've all seen the cartoon. Someone has water poured over them and it's really cold and they freeze into a block of ice. Fortunately, someone comes along with a flamethrower and a minute later, burns off the ice, and they're fine again. Maybe they shiver a bit, but pretty much they're back down. That's not how it really works, of course. If you try to freeze someone solid, the ice crystals form in their body and they rip open every cell in their body and they die horribly. Except there are some circumstances where people have been lost deep in the sea for several hours, supposedly drowned, but then brought up to the surface again, warmed up, their blood reoxygenated, and they turn out to be completely healthy. Their brains have not been damaged in the way that normally someone who has been left without oxygen, even for a matter of minutes, should be. Because the cold has slowed down their body so much that they don't need as much oxygen. There's an idea in not really scientific circles, but how can I put it? Pseudo-scientific circles, that we should be able to freeze our brains and then sometime later medicine will be so much better that whatever we were dying of, they can defrost us and then bring us back to life again. This doesn't work for the reasons that I've just outlined, that our brain cells will all be ripped apart by the ice crystals freezing. But maybe there are ways that future medicine can use cooling us to make us healthy again. There are lots of creatures that do regularly go through these huge temperature differences, so everything that hibernates lets its body temperature cool. With mammals, they still have to stay over about 16 degrees for things to go on as normal, and with the people who were drowning, their body temperature was still usually over 16, so things still keep ticking along. You can't freeze someone solid. But there are creatures that actually live in deep underneath the Arctic, and they have antifreeze in their blood. Their body temperature is actually below zero, but they need to prevent their blood from freezing up so that they can actually still move. And there are creatures called wood frogs, which actually do the opposite. They have got proteins in their blood which help their blood freeze solid, so that it takes water out of their cells, and what they then do, as their blood is freezing, is they flood their cells with a mixture of sugar and urea, chemicals which make it a sort of thick syrup, which doesn't freeze at all, even if you make it below zero. And as there's now less water in their cells because it's all drawn out into the blood, the whole creature can look frozen solid, but inside their cells it's fine. So there's nothing bursting the cells, and they make a thunk sound if you hit them, but they're actually fine when they defrost. Now, this is interesting for another reason, because there is one mammal that can do something similar. It doesn't freeze itself solid, but it does go to about 0 degrees. It's called the Arctic ground squirrel. And what's the weird thing about this, and to a limited extent other creatures that hibernate, is that when they freeze, their brains shrivel. Neurons are the sort of cells that you find inside your brain, and normally they need to sort of touch each other or come near each other in order to communicate. They've got what's known as a synapse, which is basically the gap between two of these neurons, and they talk to each other by sending chemicals across this gap. Now, when they freeze, the neurons shrivel, and the gaps are no longer as well defined. But then, when they unfreeze, they need to make these gaps sort of become the right size that you can talk across them again. And they send a protein across that does this. It's called RBM3, and the weird thing is that it seems to have this ability to rebuild these synapses. Now, we've looked in mice at how this works. With mice, they can't go to quite such low temperatures, but they also have this protein released if you just take them down to 16 degrees. And we think it happens in actually most creatures, certainly the ones that hibernate. You take their temperature down, maybe just for a few minutes, and then bring their temperature back up again, and afterwards their brains will repair in this way. But if these mice suffer from Alzheimer's, which is a disease that causes loss of memory and is linked to having a breakdown in these synapses sometimes, they will find that they suffer Alzheimer's more slowly because of this assistance in rebuilding their synapses, except if the Alzheimer's has already gone so long that actually they no longer have this protein. Similarly, if you can genetically engineer your mice to just have more of this protein expressed, this also protects the mice against Alzheimer's. So it looks as though this protein that is normally released when things freeze and then defrost, it's called a cold shock protein because it's how your body deals with sudden coldness, seems to protect against this terrible disease. There are actually in humans already some small-scale attempts to use cooling of the brain to prevent damage that's done to infants that don't have enough oxygen. So in the same way that these swimmers can survive at great depths without oxygen for a long time because their body is cooled, babies who are born prematurely and don't have functioning lungs or for whatever reason aren't getting enough oxygen to their brain, normally as they develop they'll have some signs of brain damage because of what happened to them at such a young age. And people have tried just giving them more oxygen, but actually this can sometimes make the problem even worse because the oxygen is a very reactive chemical and it can cause more problems if it's in a cell that's already panicking because it's not being given enough oxygen previously. But if you cool the brain down, not by a lot, just 6 or 7 degrees, you can have protection from the effects of not having enough oxygen. And so they've got babies who have their heads being cooled just for a short period whilst they're developing. And there are suggestions that maybe we could use something similar to this, maybe chemicals that mimic the effects of this protein in humans to prevent Alzheimer's from being such a terrible disease. So if you are finding that something terrible is happening and you're in a panic and maybe you're also having trouble with your memories, well, keep a cool head and maybe things will work out.